This is the second part for lesson 3.1 on arcs, circles, and angles. So in the last part we learned about some vocabulary words, and we also at the first part had some different angles that happen with circles, and we're going to apply those now. So in this first few questions we're going to solve for x. So let's look at number 1. We've got a circle with center O. We have got some central angles, and I know that they're central angles because they're going from the center. We've got a couple of those. A couple of things I do know that these two are equal to each other because they're vertical angles. They're formed by two intersecting lines, so that's something to keep in mind. I do know that these pieces are congruent to each other, and I'll explain how that helps also. And then I've got all these radii, which is plural for radius, right there. So I have to solve for x. So a couple of things. If you have a chord in a circle that's congruent to another chord in the same circle, so if those two are congruent, then the arcs that they intercept are also congruent. So what I do know is that since this chord is 8x plus 92, this chord is also 8x plus 92 because the two chords I have in green are congruent. So what I can say is that since this angle is 5x plus 284, it's going to be equal to the arc that it cuts, and so that's 8x plus 92. So I can solve that. I'm going to subtract 5x from both sides, and then I'm going to subtract 92 from both sides. And then I will divide both sides by 3. And so that tells me that x is equal to 64. Now if I go back and plug this in, so if I take 8 times 64 plus 92, that should be the same thing as 5 times 64 plus 284. Okay, for the next one, if you'll notice, we have some chords, but also notice that they're not going through the center of the circle. That's really important to take notice of because, well, the chord's going through the center, but the angles aren't going through the center. So we need to make sure we can understand that this is not a central angle because that vertex is not the center of the circle. We've got to notice what type of angles we do have. So there's a couple different ones we could use, but it depends on what we're given. So if we have this angle 44 degrees and this is where our x is, let me look at the angles that are formed or that are forming those arcs. So that's what I'm going to be looking at. So if you look back on the previous part, it looks like this inscribed angle where you have this vertex on the circle and it's creating this angle, and then it's intercepting this arc. And so we have this formula that's going to work for that. So if we look, that's what we have here. So we're going to set up an equation. So according to what we see, we're going to take the angle and it's equal to half of the arc. So I'm going to take the angle that's inscribed and it's going to equal half of the arc. Which makes sense because the angle would be less than this arc would be. If you think about like if that was a central angle, that would be a bigger angle measurement. So 44 degrees, that seems reasonable for the picture. You're going to solve this, so 1/2 of 8x, 1/2 of 8. You can divide everything by 4 here, and then x is equal to 10. So this would be 8 times 10 plus 8, so this is 88 degrees, and then this is 44 degrees, so that works according to what we see in our inscribed angle there. Now, before we leave this picture, let's just take a look at some of the other things that we see. We also have some interior angles because I have these chords that are forming an angle inside the circle but not a central angle. And so if I had different information, I might say this angle is equal to half of this plus this. So just, you're going to see different kinds of questions that are going to have those things. So it's important that you can identify which of these situations we're looking at. Okay, looking at the last one in this section, we're going to find the values of A, B, C, and D. So we've got this quadrilateral that is inscribed in the circle. So inscribed just means that all of the vertices are on the circle. And we have to find the missing angles. So we do know that in a quadrilateral, because it forms two triangles, 180 plus 180 is 360. So we do know that all the angles are going to add up to be 360. So I know that A plus B plus 92 plus 108 is going to equal 360. However, because I have two things I don't know, that's not immediately helpful. Let's look at what we do know. We do know that we have some angles that are inscribed. So I've got this 108, that angle, and it's going to equal half of that. I could set up an equation for that. I could say 108 is equal to half of C plus 114. You can solve that and find out what C is. Let's think of some other things that we could do. If I knew that this one is 92 right here, I would know that 92 is equal to half of 114 plus, I don't have a name for that one, so I could call it something else if I wanted to. I could say 92 is equal to half of 114 plus E, and so I could solve for this little piece right there. However, since that's not one of my A, B, C, D's, I'm not immediately concerned about solving for that. I do have a really good option right here because it's solving for one of the variables I need, so I'm going to go ahead and do that. I'm going to multiply this side by 2 and just get rid of my fraction. So I'm going to have 216 is equal to C plus 114. So C is equal to 102. And so this angle, or this arc measure, is 102. So then now let's look at B. So if I look at B, I could say that B is equal to half of 102 plus D. Okay, I've got two variables there, so that's not what I want exactly. Let's look at some other angles. One thing I know about a circle is that it's 360 degrees around. So I don't have to know the radius or anything of a circle because all circles are 360 degrees. So I do know that the entire circle, as far as degrees goes, is 360. So if I take the ones that I know and I subtract the 114 and the 102, I would have whatever is left right there. So let's do that. So 360, take away 216. That's 144. So I do know that this arc is 144 degrees. Now, that doesn't help me find D immediately, but what it does help me do is it helps me find A, because this angle A is going to be half of 144. So half of 144 is equal to 72. And so angle A, let's write this, angle A is equal to 72. We already found what C is. C is equal to 102. So we're starting to put all of these pieces together. So I'm going to write this again. This is 102. This is 72. Now, since I know three of the angles of a quadrilateral, I can find the last angle by taking 360 and subtracting 72, 92, and 108. So if I did my math right, that's going to give me 88 degrees, and so that's going to be what B is. So I'm going to just come write this right down here. B equals 88 degrees. And of course, you can check that because if you have 108, 92, 88 degrees, and 72, it all needs to add up to 360 degrees. So that's how you know that that would be true. Okay, so I have three of the four pieces. I'm going to fill in that this one is 88 degrees. And so I can use that now right over here because I said earlier that B is equal to 1/2 of the 102 plus D. And so I can just solve that equation. So I'm going to multiply by 2 on both sides. And so D is going to be equal to 74. So that's my last piece. So this is 74. Now you could also find that one now. And it would also have to fit the puzzle because it's going to have to fit that 92 would be half of 114 plus whatever that piece is. There's a lot of ways you can check and see what you're doing because you know what they all have to add up to be. But as far as the answers to that, there is all of the answers. Okay, we're going to move into some other practices. First of all, we're going to find the value of x and also classify the angle. Is it a central angle, an inscribed angle, and interior angle? Let's go ahead and do all the classifying first. So numbers 1, 2, and 3, circle the word for which type of angle is being shown in the picture. Okay, number 1, this is a central angle, and I can tell that because the vertex is in the center of the circle, comes out and touches the circle. Number 2, this vertex is the center of the circle, so these are also central angles. Number 3, vertex in the center, also central angles. So all of these that I'm looking at on 1, 2, and 3, these are all central angles. And that's good because they're all going to just operate the same way so I can get used to how that works. So remember that a central angle is equal in degree measures to the arc that it intercepts. So in this case, x would just be 52. You're not going to say 52 degrees because it says up here x degrees, so 52 is fine. Okay, number 2, we have this angle x, so this would be x, whatever that is. This is 130, so that means that this is 130 because it's a central angle, and this one's 136. So how do you find x? Well, remember we know that a circle is 360 degrees, so I'm going to say 360, take away 136, take away 130, and you'll get the answer to x. So x is equal to 94. So again, I'm not going to say 94 degrees because it says x degrees in the middle, so I don't need to say degrees again. Okay, number 3, this right here, this is a diameter, and so it cuts my circle in half. So I know that this semicircle is 180 degrees. I know that because this angle is 180 degrees. And so I can use that to find the missing piece right here. This angle right there, that central angle is going to be 125 because it corresponds with the arc. So you're just going to do 180 minus 125 and get 55. Okay, moving to the next one. Number 4, the vertex of the angle is on the circle. So if you look back at where we had these descriptions, which one does that look like? Okay, hopefully you thought that it looked like the inscribed angle. The vertex is on the circle. And so what happens there is this is 39 degrees, so x is not going to be 39 degrees. You're going to take half of x and it will be 39 degrees. Alternatively, you could say 2 times 39 degrees is equal to x, and so that's going to be 78. So this arc right here from C to D, that's 78. Okay, number 5. Oh, we're supposed to classify that. Okay, number 5, the vertex of the angle is inside, so it's not a central angle because it's not on the center, but it's not an inscribed one because it's not on the circle. So this is an interior angle. This is probably the hardest one to remember the formula for, but what it is this this angle is equal to half the sum of these two right there. So angle x also, this is going to be vertical angles right there, so if we just say x is equal to half of 55 plus 125, then it becomes a simple math calculation. So that comes out to be half of 180, which is 90. That means that x is equal to 90 degrees. So if I look at this angle, if this was drawn to scale, that seems reasonable. It may not be drawn to scale, but it looks pretty good, and the math backs it up. So we're going to say 90 for x. Okay, and the next one, I've got a couple of things. I've got a central angle right here. So that's a central angle, but that's not unknown. So I know what my central angle is, so that's not the one that we're asking about. This angle right here that's x, which one is that? The vertex is on the circle, so this is an inscribed angle. And so again, think about what the formula is for that. This is equal to half of this arc. How do I know what that arc is? Well, I know that the central angle is 134. That makes this 134. So x is equal to half of 134. So that makes x equal to 67. And so that inscribed angle is 67 degrees. Okay, the last few examples, I want you to pause the video and I want you to try to do the last 3 examples as much as you can, and then come back and see if you did it right. If you have any questions, make sure you ask. Okay, for number 7, we're looking for this angle right there, and that's an inscribed angle. As far as what do I know, nothing's labeled there, and so you might be thinking, oh no, what do I do? But remember that from here to here, this is a semicircle right there. And so a semicircle is half of the circle, so this is 180. And so this angle cuts half of the 180. So half of 180 is equal to x, and so x is 90 degrees. Now that brings up something that when you see an inscribed angle, if it does what we say intercepts a semicircle, it has to be 90 degrees for that reason. So if you ever have an inscribed angle that's cutting half a semicircle, it's 90 degrees. There's nothing else it could be. Okay, number 8, if we look at our angles right here, these angles are formed by some intersecting chords. It's an interior angle as far as what we're talking about right there. I know 30 degrees, 90 degrees. Unfortunately, that's not the one I'm looking for. I'm not looking for these angles right there, so that's not immediately helpful. Note that this is not a semicircle. That's not a diameter, so I can't say 180 degrees minus 90 or anything like that. What I'm going to need to do is I'm going to need to kind of solve an alternative problem first. So I'm going to call this angle right here y, because I can find what that is. I can say y is equal to half of 90 plus 30. So y is going to be half of 120, so it's 60 degrees. So if I know that this angle right here is 60 degrees, because this is a straight line, this would have to be 120 right there. So then what you can do is you can say 120 is equal to half of x plus 2x. And as long as I only have one variable, I can solve that. So if I multiply both sides by 2 to get rid of my fraction, and so x is equal to 80. So you look back and see if that, seems to make sense. If this is 80 and this is 160 plus 90 plus 30, does it add up to be 360? It would have to be, or else something's wrong. Okay, I'm sorry, that's an interior angle. Okay, last, this is a central angle. Since it's 64 degrees, that means this is 64 degrees. Because this is a diameter, goes through the center, this is half circle, 180. So if I just do 180 minus 64, I'm going to get what x is. So x is also, it's talking about the arc, but it would be the same as if I was finding that angle right there. So it's just basically the supplement of it. So that's going to be 116. And so that's what x is. Okay, you need to make sure that you understand the 3 types of angles, so central, interior, and inscribed, and make sure you understand how to identify them and then how to use the formulas that we talked about on this part right here. As far as the vocabulary words that we did at the very beginning of the lesson, we'll keep going over those things and seeing where they apply in circles, but this is the main point for today's lesson.